Welcome to Bite-Sized Data Science. One set of time series data that we all have heard a lot about over the last year or so relates to COVID-19. Let's see where we can get the data and how we can use it to get some insights. Let's get into a notebook. I'm using the IBM Watson Studio environment to run my notebook. If you are interested, you can find a link in the description on how to create a free account on that platform. Links to the notebook I am using here are also available in the description. The Socrata API gives us access to the open government data. This includes data from the Center of Disease Control. The CDC makes over 600 datasets available. Out of these, over 60 mention COVID. There are so many to choose from. Without looking in details, I would venture that most of these are time series datasets. This shows once again that time series have to be created with a specific purpose in mind. Each new purpose then requires a new time series. Let's look at the United States COVID-19 cases and death by states over time dataset metadata. The ID attribute allows us to retrieve the data itself. The metadata includes a textual description of the data and much more. What's important to us is the name of the attributes and their types. By using the ID attribute, we can retrieve more detailed information such as the count of non-null values for each attribute. This can indicate which attribute may be discarded in our analysis. A lot more information is available in the metadata. After reading the records, we convert the columns to their proper types. We also sort them chronologically by submission date. Note that at least in the early days, there is a significant difference between the submission date and the time the record was created. We can see that the first record was submitted on January 22nd, but the record was created over 2 months later. Even for the last records, there is 1 day difference between the reading and the posting. We need to keep this lag in mind when using the most recent data. We're limiting ourselves to 6 attributes. Let's see how Oregon has been doing in the last few days. We can see a lot of variation in the new cases attribute from day to day. Let's plot the data on a line graph. We can notice a few readings where 1 day is high and the next day is 0, or vice versa. The worst one is when it even goes negative in August 2020. Also, despite the recent trend downward, it may not be that great yet considering that the level is still about the same as July to October 2020. Let's see how New York is doing. Can we compare Oregon and New York? If we only look at the numbers, we can see that Oregon has much fewer cases than New York, but are they doing better? To find out, we need to normalize the data to make it comparable. New York has almost 5 times the population of Oregon. To compare, we need to take that into consideration. Let's look at the number of cases per 100,000 residents. The resulting graph tells us a different story. We can say that over the last 2 months, New York is doing better than Oregon. We could take it a step further and see how different states do against the national average. The graphs are instructive, but since the number of daily cases has gone down in the recent months, it would make more sense to graph only the last few months. Finally, let's plot a few states on one graph. We can see that Arizona was the worst state last summer, then South Dakota in the fall, and more recently, Michigan in March and April. We'll continue our exploration of this COVID time series in the next video. See you next time on Bite-Sized Data Science, and don't forget to subscribe.